Okay, so for number 27, it says find the period of each sine curve. Well, the period is how long it takes to make one complete cycle. So if you look at the graph, it's a sine curve, and it starts down there, it goes like this, okay? Tell me when to stop when I have completed one cycle of this graph.
You going now.
Okay, this is one cycle right to here because it's gone up, down, and back up again. Okay, so now you need to look at the book and say, and look at the graph and figure out how long did it take to do that. Well, this right here was pi.
2 pi.
Right, and so this right here is going to be 2 pi. So the period of that function is 2 pi. Well, in a normal sine graph, when we were looking at them on the calculator on Wednesday, what's the period of a normal sine graph? No, but how long did it take it to complete one cycle when we graphed the regular thing? 2 pi. Okay, so this is a regular old news is what you're saying, sine of x. Okay, remember when we put like a 4 in front of this x, then we got 4 cycles in between 0 and 2 pi. And since we only get one cycle in between 0 and 2 pi, that means we just have a 1 in front of the x. Then the only other thing you need to figure out is the amplitude of the graph. What is it? You do if you're going to come up with an equation.
It's 2.
It's 2 because it goes from -2 to 2, so that means I need a 2 in front of my sine of x. Okay? So find the period of each sine curve. The answer is 2 pi. Then write an equation for each sine function. The equation for this sine function would be y equals 2 times the sine of x.
Okay, we
All right.
can do that.
What for?
Can I answer number 6 in class?
Number 6?
Yeah, I don't know.
1.
1.
It was 1, Jenna.
I don't really understand what you said.
Well, you go over to pi over 2 on the x-axis, and then you go up to the graph, and you see that it's
Wait,
a
so
y
28
value of
would
1.
But what if it's like 5 radians?
Then you need to figure out where 5 radians are. And remember, pi is 3.14. 2 pi is going to be about 6.28, so you got to find out where on the graph 5 is if you're going by pi. Okay? Okay, so 28. How long does it take to complete one cycle? 2 pi. So once again, the period is 2 pi. Okay? Then to write the equation, I got a couple of different things going on. What do you notice first off? It goes down instead of up, so that means it's going to be negative. What's the amplitude? 3, so it's going to be -3. Sine of, and since it completes one cycle in the 2 pi distance, you put a 1 in front of the x, or just leave it as a x. Yeah, so for example, if you look at 29,
7.1.
how long does it take that to complete one cycle? What's your scale? What's your scale? Yeah, it takes pi to complete a complete cycle. Okay? Because it goes up, down, and back up again, and then up, down, and back up again. It does 2 of them in 2 pi, so the period there is going to be pi. So your equation is going to be y equals, what's the amplitude? Be careful. 2.5, nice. Sine of, and since it completes 2 cycles in between 0 and 2 pi, it's going to be sine of 2x. Okay? So do not know.
30 is
Okay, so 30.
3.
How long does it take to complete one period? Pi over 3. Okay? So this is going to be a little bit tricky. Okay, first the easy part, the amplitude is 0.5. Then we need to figure out for the number that goes in front of the x, how many cycles does it complete between 0 and 2 pi? And so here's what's going on with that. The way that you find that, if you can't look at it and see it, is you take 2 pi divided by the period, right? Right?
Yeah.
Because if the period is pi, then obviously 2 pi divided by pi would be 2, and that's what we came up with. If the period is 2 pi, then 2 pi divided by 2 pi is 1. So if it's something wacky like pi over 3, and it's not quite easy to see, you're going to go 2 pi divided by pi over 3, which is 2 pi times 3 over pi, because you invert and multiply. So those cancel. Whoops. So those cancel, and so it's going to be 6. Okay? So if you can't just look at the graph and count it, then you take 2 pi divided by the period and go from there. So those of you that said 3, you're right that it does. Oh, no, you're wrong.
Uh-oh, you're recording too. Tokyo.
Okay, what else? Yeah.
Okay, for 7, you know how the sign is 0?
For 7, okay?
Every year I have that's 2.
Right, because they're just estimating. And so they said that really it's going to be a little bit past that. But if you said 0 and they're estimating 0.1, we're close. Okay, anything else?
Yeah, it was
31
how was it not
36.
negative?
Huh?
How was it not negative though?
It's on the x-axis, so.
Well, you're looking at number 7, says 3 radians, right? Well, 3 is just to the left of pi.
I was gonna 9.
What did you say?
31 to 36. Just
31 through
Making
36.
love.
Are they like the same as the other one that we were doing?
Yeah.
Is everybody like negative?
Okay. 31 through 36, you'll be happy to know, are the easiest problems in the world. Determine the number of cycles of each sine function in the interval from 0 to 2 pi. Well, that's the number that's in front of the variable.
OMG.
So that's 1. Okay?
Yeah, we're serious, yeah.
I got in trouble, so they have to get.
Don't talk, Mom.
Find the amplitude and period of each function. What's the amplitude of this? 1. What's the period?
What is happening?
2 pi. Okay?
Because they all.
Because it completes 1 cycle between 0 and 2 pi.
So number 32 would be
32
5.
says y equals sine of 5 theta.
5, 5, 5.
So how many cycles will it complete from 0 to 2 pi? 5. What's the amplitude?
1.
No, 1. Okay? And what's the period? If it completes 5 cycles in 2 pi, the distance 2 pi, the period's going to be 1/5 of 2 pi, right?
1/5.
Yeah, because here's your interval from 0 to 2 pi,
Oh, okay, I got
and
it.
it goes 1, 2, 3, 4, 5 in there, right? Okay, that's an awesome sine graph. So your period for one of these is going to be 1/5 of the whole thing. So what's 1/5 of 2 pi? 2 pi over 5.
That is good.
Okay.
I, 1.
Okay, 33 says y equals what?
And then pi, and then
Sine of pi theta.
2 pi over, so it's just 2 pi. Right?
So how many cycles does it complete? Right, pi number of cycles, 3.14 cycles. What's the amplitude? 1. And what is its period? 2.
Because of pi signs.
So the pi's cancel.
You're seriously getting
So for like.
Okay? So here's what's going on. Let me give you the magic bullet that you should write in your note.
I did it.
Wait, 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 wait.
Did you say magic bullet or magic bullet?
This is the cheat sheet thingy that you can now have because you can clearly understand the concepts since we're walking through these. The general form of the equation is y equals a times the sine of b times x, okay? A is the amplitude, that's pretty easy, right? The tricky part is this whole b period thing, okay? If they asked you to find the period, you just go 2 pi divided by b, because b is the number of cycles that it completes between 0 and 2 pi, right? So if b is, 1, then the period's going to be 2 pi, and it just made one of those in there. Or if they want you to go the other way around and look at a graph and come up with the equation to find out what this number is that goes here, what we were doing is we were going 2 pi divided by the period. So depending on which way you want to go, if you want to know the period, you go 2 pi divided by b. If you know the period and you want to find the number that goes in front of x so you can write the equation, then you go 2 pi divided by the period. Okay? So that should be in your notes, and that should make all of these problems really easy. So 34.
Is it 2 pi?
The number of cycles it completes is 1. The amplitude is 3. And since b is 1, 2 pi divided by 1 is 2 pi. Okay? So for 35, the amplitude is not negative 5 because the amplitude is a distance, so it's always positive. It's 5. Okay? The number of cycles it will complete is 1, and the period is 2 pi. For 36, the amplitude is 5. The number of cycles it will complete is 2 pi, which means the period is 1. 2 pi divided by 2 pi.
You take 2 pi divided by 1/2. It's 2 pi times 2 over 1.
Correct.
So is it 1?
Okay, task 4, please.
Have another assignment that afternoon.
Okay, don't turn